Hi, everyone. Welcome to the Compton scattering experiment. And here's the equipment we're going to use, a gamma ray spectrometer, okay? Now, the gamma ray detector, the basis of the spectrometer, is actually inside of that lead-lined box. We'll take a look at it in a moment. But notice a few other things that are sitting around it. There's a storage container here that's full of liquid nitrogen at 77 Kelvin. And here's a big storage container of liquid nitrogen, which we just use to refill that one when it goes empty. We'll talk about what those are for in just a moment. But first, let's look inside of the box. Okay, I'll open the box now. Top's a little bit heavy. There we go. Now let's look inside. I'm going to pick up the camera, so apologize if it wiggles. There we are. We're looking inside now, and what you can see is first there's a copper shielding around the edges, and then deep inside you see a silvery can, and the gamma ray detector is mounted inside of that. In order to operate, the gamma ray detector has to be at low temperature at 77 Kelvin, and it's cooled with liquid nitrogen to hold it at that temperature. Then it's mounted essentially inside of a thermos bottle. That's the silvery can that you see. And then the bottom of the, and then it's actually mounted on a cold finger, which goes through the bottom of the thermos bottle into the liquid nitrogen. That keeps the whole arrangement cold. And now you know what the storage container of liquid nitrogen is for as well. When we want to use this, we can place our sample into the system. In this case, the sample is just a cesium-137 test source. And we can even just place it on top of the detector like so. And now we're ready to go. If we're really worried about background, we can also close the top of the box. Here, let's see what a measurement of this source looks like. All right, here's the program that controls the gamma ray spectrometer called ProSpec. We can set up the detector. In our case, the only thing we have to change is the data acquisition time. For this sample, we're going to use a time of 10 seconds. But for our other measurements, we'll use times more like 5 minutes or 300 seconds. We know our sample is already mounted in the spectrometer, so we can go ahead and hit run. Here we go. Hitting that arrow starts the run. And now we're taking data. Oops, I'm going to zoom out. There we are. So we can see the whole range. In this graph, the x-axis is energy in thousands of electron volts. So the maximum is 2,500 keV, or 2.5 mega electron volts. The y-axis is just counts, or gamma rays detected. All right, it's all done. In our spectrum here, we see one big peak and then some other weak background that we can look at in a moment. Let's look at this one big peak here, shall we? So I can move my mouse over to it and then select zoom into region. There's the peak again. I'm going to zoom in once more. There we are. Don't worry about the background coloring that's constantly changing. That's the program trying to identify and fit this peak. We can ignore that. I'm going to change the vertical scale, and there we are. There's our peak. Notice when I bring the mouse over to the peak, a window opens here that shows us some information. The center of the peak, the number of counts, and some more information as well that might be interesting to us or useful. All right, let's zoom out. And we'll zoom out once more. Now, let's look at this weak background. So we'll zoom into this region, okay? It looks a little bit funny here. First of all, I'd like you to ignore all the coloring. Yes, it's blue here, and there are some places where it's red. Those are just some analysis regions that another user has set up. We don't need to pay any attention to this. All that we care about is that we see this background, which kind of smoothly changes, okay? These are gamma rays that scattered inside of the spectrometer, and their energy changed. So instead, they started out at the energy that we saw before, 663 kilovolts, but now we're at much lower energies. These are, in fact, Compton scattered gamma rays. However, in this case, we don't really know what they scattered off of or what the scattering angle was, so we can't use any of this information in our analysis. Anyway, it's still interesting to see. Here, let's zoom out again. And there we are. When we're done with this, we might want to do a couple things. We could save it. To save the data, we go to this tiny little icon over in the corner marked that looks like an Excel file and click that. Export data. And then off it goes. And we can save it here. I won't bother to save it this time. And that will give me a file that I can open in Excel. If I want to clear the data, I can hit this. And now the data is cleared. All right? And we're always going to want to take spectra, save them in this Excel format, and then after we've done that, but not before, then clear it for our next measurement. So I think we're good to go. Okay? Okay, well now let's talk about how our measurement will actually work. We want to measure Compton scattering from gamma rays that scatter off of this aluminum block. And we want to control the geometry, the scattering angle. Here's how we'll do it. We'll use our radioactive source like this one, and we'll place it over the detector. Here in this, while we're playing around, imagine the detector is right here, okay? What we're going to do is first to place a lead shield on top of the detector, like so. Then we'll place the source directly on top of that. What that does is it prevents the source from seeing, it prevents gamma rays from the source from traveling directly to the detector because they'll be stopped in the lead shield. Instead, they have to travel out, scatter off of something, and then come back. So when we do our measurement, we'll simply place our scattering block here and measure the signal, which will include gamma rays that scatter off of the aluminum block. Okay, perfect. We'll have to do this measurement for about 5 minutes to get enough counts to get good statistics, but it should work fine. Now there is one thing. You remember in our last measurement, we saw lots of Compton scattered X-rays from just all over, things that reflect off of different parts of our apparatus. Well, we don't really care about any of that. So in order to remove that from our measurement, we'll do a second measurement, a background measurement. In the background measurement, it will be exactly the same, only we remove the aluminum block. When we run the experiment now, all of the scattered gamma rays that we see will all be due to background, okay? And then the data that we analyze will actually be the difference between our measurement with the block and our measurement without it. It's actually kind of straightforward, but the results should be interesting because we'll see that the energy of gamma rays scatter when they scatter off of something like this aluminum block. And we can predict exactly how it should change using the Compton scattering formula. At least that's what we're here to test today. All right, well, I'll see you in lab.